Dear students, in this video, we are going to prove De-Moivre's theorem of complex numbers by mathematical induction method. According to De-Moivre's theorem, r cos theta plus I sin theta whole power n equals r power n cos n theta plus I sin n times theta. The power, that means n, multiplies both the cosine and sine angle. So this is called De-Moivre's theorem. Now we are going to prove De-Moivre's theorem. So we are going to follow mathematical induction method. In the mathematical induction method, there are three steps. First, we take the value of n equals 0. Then we prove LHS equals RHS. Then we assume that this statement, that means De-Moivre's theorem, is true for any positive integer n equals k. Then at last we prove that this theorem is true for any positive integer n equals k plus 1. Hence, by the mathematical induction method, we can say that the given statement or the given theorem is true for any positive integer, or we can say any natural number n. So here we go. Let Pn, in mathematical induction method, the given statement we suppose as Pn. So P1 equals r cos theta plus I sin theta whole power n equals, which we have to show, equals r power n cos n theta plus I sin n theta. So when n equals to 0, LHS equals r cos theta plus I sin theta, then whole power 0. Dear students, if we take whole power 0, then we get the value of LHS equals to 1, because any number raised to power 0, the value equals 1. Now let's take RHS. Now RHS is Rn cos n theta plus I sin n theta. So if we take RHS, which is Rn cos n theta plus I sin n theta, and if we put the value of r 0, if we put the value of n equals to 0, then cos n means 0 times theta plus I sin n means 0 times theta. So r power 0 equals n, and the value of cos 0 is 1. 0 into theta means cos 0 plus I sin 0 into theta means 0. Cos 0 means 1, so we get 1 plus sin 0, the value of sin 0 equals to 0, and 0 times I we get 0. That means we get again the value of RHS, we get 1. This means this theorem is valid for n equals to 0. That means when the power is 0, then the value of LHS and RHS we have got equal. So according to mathematical induction, let Pn, that means given statement, is true for n equals to k, where k is a positive integer. Pk equals to r cos theta plus I sin theta whole power k. So this is LHS, which equals rk cos k theta plus I sin k theta. Now we shall show that this theorem is true for n equals to k plus 1. We'll show that this theorem is true for n equals to k plus 1. So when we take the value of n k plus 1, we get the given statement p k plus 1. So by putting the value of n equals to k plus 1 in the given statement, we get p k plus 1 equals r cos theta plus I sin theta whole power k plus 1 equals r power k plus 1 bracket cos k plus 1 times theta plus I sin k plus 1 theta. We are going to show that the given statement is true for n equals to k plus 1. So we shall prove that. We are going to prove that LHS equals to RHS. So let's take LHS. LHS equals r cos theta. LHS equals r cos theta plus I sin theta. R cos theta plus I sin theta whole power k plus 1. So we'll break down this into two parts by using the laws of indices. So we can write r cos theta plus I sin theta whole power k plus 1 as r cos theta plus I sin theta whole power k times cos theta plus I sin theta. So dear students, we have supposed that pk equals r cos theta plus I sin theta whole power k, which equals rk cos k theta plus I sin k theta. So now we are going to substitute the value of r cos theta plus I sin theta whole power k. R cos theta plus I sin theta whole power k we can write as rk cos k theta plus I sin k theta, and this part cos theta plus I sin theta as it is. So dear students, after multiplying rk cos k theta plus I sin theta k with r cos theta plus I sin theta, we get r power k into r, we get r power k plus 1, and according to the multiplication rule of complex number, the angles are added. So cos k theta plus theta. So this is the rule of multiplication of complex number. If a complex number is given in trigonometric form, then in multiplication we add the angles. K theta, when we multiply with sin theta, we get k theta plus theta. So angles are added. So after adding k theta and theta, we get k theta plus theta. So dear students, after solving this, we get r power k plus 1. So if we take theta common, we get cos k plus 1 times theta plus I sin theta, I sin k plus 1 theta. So this is the RHS. So dear students, in RHS we have rk plus 1 cos k plus 1 theta plus I sin k plus 1 theta. So we have got the value of LHS and RHS both equal. So dear students, we have got the LHS equals to RHS. Hence, by the mathematical induction, Pn is true for all n belongs to n. Hence, it is proved. So dear students, thank you for watching this video, and I hope that you have understood how to prove De-Moivre's theorem, which is one of the most important from examiner's point of view in any examination. So thank you very much for watching this video. Have a nice day. Thank you.